Hi there. Well, some of you have finished chapter 7, the test, and so I thought I'd go ahead and um, uh, start by looking at chapter 10. And let's see, I'm trying to get rid of this. Oh, well, maybe it'll disappear. Now, this chapter deals with radicals, and it does give some people a hard time in the past, or the radicals. And I have talked with other teachers, and I'm not sure if it's because some of the ideas are so new, but we're going to go ahead and we're going to start with the very basics and work our way up. And then we'll just have chapter 11 to finish up, and then we'll take the final. But I'd like to spend at least 2 weeks on this chapter alone and give you guys some time to work through some of the problems. It's really important that you do the homework assignments so that you have an understanding of this. Now, in looking at this, this section here, we're not only going to be talking about square roots, but we're going to be talking about cube roots, fourth roots, fifth roots, and we'll explain those. But for right now, we're going to spend some time on some square roots. Some of you may have seen these before. So let's go ahead and look at these. Now, when we talk about a square root, when you're actually talking about a square root, as far as the formal definition of a square root is, they use a c-squared in the notes, but we're gonna use an x-squared. Now, the formal definition of a square root is a solution to this equation. What are the x's? And a is some number. So when they say find the square roots, they're asking you to find the solutions, or whatever the x's are. Now, let's do an example. For instance, if I had x squared equals, I don't want to do one that we'll be doing later. Okay, x squared equals 4. Okay. Now, what are the square roots of 4? What are the square roots of 4? Are the square roots of 4. They're asking you to solve that equation. What are the x's that you can put in? Well, a lot of you say, well, 2, because 2 squared is 4. So a solution to this equation is 2. However, some of you forget that that kind of looks like a z, but that's all right. Another solution to this is a -2. And you don't want to forget about that because you could put in a -2. So in other words, if you have a +2, so 2 squared equals 4, but also a -2 squared equals 4. Notice the parentheses that I put around that -2, which you would need in a calculator. So the two solutions are 2 and a -2. And so those are called the square roots because they solve the equation that's right here. So again, we're going to have those two answers here. When they ask you to find the square roots of a number, there are actually 2 of them because they're asking you to solve this equation. Well, let's look at some examples that I sent you in your notes. And they use a c here instead of an x, but you're solving it for the c here. All right, what are the square roots of the following numbers if they exist? And we'll talk about that here in a minute. But what are the square roots of 9? So what they're asking you for is solve that equation right here. What x's, when you square them, give you a 9? And I'm using that instead of a c because we're used to seeing x's. Now, you could say 3, because 3 squared is 9, so it's a solution. So a square root of 9, one of them is 3. The other is a -3, because a -3 times a -3 is also 9. So again, the square roots, and there's a key right there, it's plural, are 3 and a -3. Now let's look at their next one. We've got 25. What are the square roots of 25? And I want to get rid of that. Uh-oh, sorry about that. So, oh well. What are the square roots of 25? Well, the square roots of 25 would be a solution or the solutions to this right here. So you would have 5, because 5 times 5 gives you 25. So you could put in a 5 there. 5 squared is 25. Also, negative 5 is also a square root of 25, because the square roots are these x's right here that you square to get that number. Negative 5 times a negative 5 is a positive 25. All right, so those really aren't too bad. Let's look at this next one though. What are the square roots of a negative 4? So they want you to solve this equation right here. What x's can you square and get a negative 4? Well, the problem is that the numbers, this means you're taking a number times itself. So we know it's not 2 times 2. It can't be a positive 2. And I know it can't be both negative 2. And because we're taking the same number times itself, you can't take the same number times itself, because 2 times 2 equals a positive 4, and a negative 2 times a negative 2 equals a positive 4. So in order to get a negative here, they have to be opposite. And we can't have that to solve this solution. We can't have opposites. We have to be multiplying the same number times itself, not a number and its opposite. So what we have here is we say that it's not necessarily that there's no solution, period. There's no, because we will find some later on, but there are no real solutions. So this one here, there are no real square roots for a negative 4. All right, so this one would be, and I can't tell you the truth, I can't remember what MyMathLab has as an option for that one, whether or not it says no real solution or no real square roots is probably what it says. I don't think it has no solution. It's probably no real solutions. So here you can't have a negative when you're doing a square root. Okay. Well, when we simplify these, we don't want to be doing everything twice. We've already done that in absolute values, where we've had, a 5 and a negative 5. We've already dealt with that. So what we do is we look at what's called the principal square root. So we're going to kind of eliminate looking at this part of the solution. Even though we know it's there, we're going to be looking at this. So when they say find the principal square root, we're actually finding just the positive one. That's all. We're just going to find the positive one when we find the principal square root. Well, we use that a lot. And the principal square root is actually what's on your calculator, is the principal square root. The principal square root symbol is our radical symbol. Okay? That's what we use to mean the principal square root. So when you use your calculator, and you guys have probably done this before, you've used this radical without realizing that what you're finding is the principal square root. So you're finding the positive answer rather than the negative. So when you have this symbol, it means find the positive one instead of both the positive and the negative. So if they say to find the square roots without that symbol, you're going to have 5 and a negative 5. Okay, you're actually solving this equation here. But if you start using this radical symbol here, you know you're only going to find the positive one. So what comes out of this has to be positive. All right, so let's look at the square root of 25. Well, up above, we found that the square roots are 5 and a negative 5. But here with this symbol, I want the principal square root. So the answer is 5. Okay, just the 5. When you have this symbol, meaning I just want the positive, that's all, just a positive one. We're just going to ignore the negative one when we're simplifying these. Okay, let's look at this next one. I'll try to move it up just a hair. The square root of 25 over 25 over 64. Well, the nice thing is, and we'll be dealing with this a little bit later, is when you find the square root of 25 over 64, you find the square root of, or the principal square root, but I'm not going to say principal square root. I'll just be saying find the square root here. You just have to kind of remember that with this symbol, we're finding the positive answer. You do these separately. That's really not that difficult. You find, since they're both underneath the same radical, the square root radical, the square root of 25 is 5. That's our principal square root. It's the positive one. and the square root of 64 is 8. So the principal square root of 25 over 64 is 5 over 8. Okay, because 8 times 8 gives you 64. Kind of helps to have pretty good grasp of the multiplication tables, but if you don't, you've got a calculator. Now let's look at C. Now C, notice where the negative is. The negative is on the outside of the radical. So there's a huge difference between this right here and a negative 64. This one has no real solution there, or no real answer. But the other one does, because it's outside of the radical. What this one does here that they want us to find is you find the square root of 64 times a negative 1. Or you can also think of it as the opposite of the square root of 64. So the square root of 64 is 8, and then you have the opposite of that. So the answer to that one is a negative 8. And this one right here, there would be no real solution. Okay, it could not be simplified and find a real solution. All right, now let's look at the next one. You're thinking, okay, we've got 0.0049. Now the 49, you're thinking, okay, wow, the square root of 49 is 7. But what do you do about that decimal? Well, of course you can use your calculator, but without a calculator, I'm going to go ahead and go through it as if you don't have a calculator. And again, we're looking for the principal square root. So we're not looking for these negatives. And the reason I know that, I'm not looking for these negatives here. And the reason I know that is because of the symbol means just the positive one. So here, what I'm going to do is I'm going to rewrite this. Now this is tens, hundreds, thousands, 10,000s. So this is 49 over 10 thousandths. Okay. Now you can find that this is just like B. You find them separately. When they're both under the radical, you can reduce them separately and make them a fraction. So the square root of 49 is 7. The square root of 100,000 is 100. You have 4 zeros, so this would be 100 times 100. That gives you 4 zeros. So just like the square root of 4 was 2, because 2 times 2 gives you 4. The square root of 25 was 5, because 5 times 5 gave you 25. The square root of 10,000 is 100 times 100. So the square root of, the square root of this 10,000 is 100, because 100 times 100 gives you 10,000. Now your calculator probably didn't give this to you as a fraction, 7/100. It probably gave you right there, which is the same, 7/100. But now you kind of see where they got this, how you go from here to here. All right. Okay, perfect. So now we know what that symbol means. It means the principal square root, and that whatever comes out has to be positive, of course, like unless you have number C where you have a negative in front and then it just comes down. We just can't have the negative in the radical right now to find these real solutions. Okay, so let's read what we've got down here. We can also have variables inside. So this is maybe something that you haven't done before. So this may be the new part. We can also have variables inside of square roots. These are called radical expressions, just like we had rational expressions, fractions, in the last chapter. We call the quantity that appears under the radical sign the radicand. So what we now have is we now know that this is called a radical sign, and we're coming up with some definitions to describe what we've got here. Inside, underneath our radical, is the radicand. So if they ever refer to the radicand, it's what you're taking the square root of, is all we have. And we'll have some other things that we'll talk about too as far as these parts. But that's called the radicand. All right, so let's go to our next page here. And we're just going to kind of work with radicals and the radicand. and then we'll eventually start simplifying them. And I may have to come up with some other type of examples. All right, let's work with these radicals here. First off, all they want you to do it, and we've been doing this since, the end of chapter 5 and some in chapter 3, is whenever this is read f of 1, so all you do is you put 1 in for the x and see what it is equal to. So we're putting these into the radicand, all right, what's underneath our radical. Okay, let's look at an example. Let's do this one right here. So we'll have f of 1 is equal to the square root of 3 times 1 minus 2. That's all that means, which gives us 3 minus 2. The square root of 1 is 1. And again, we're looking for the principal square root. We're using the symbol, so we want the principal square root. And it's 1 times 1 is 1, so the square root of 1 is 1. That's all. All right, let's look at our next one. F of 2/3. So we're going to put in 2/3 for our x's. And let's see, 2/3 times 3 is, the 3's cancel. It's actually 3 over 1. You can put your whole numbers over 1 here if you need to. So we end up with 2 minus 2. Let's go ahead and write that down, which is the square root of 0. The square root of 0 is 0. So you can have a square root of 0 as long as that square root of 0 is not in the denominator. Then we have some other issues. But as long as the square root of 0 is not in the denominator, then the square root of 0 is 0. All righty? Okay, let's do one more. Let's put in 0 now. So we have 3 times 0 minus 2, which gives us the square root. 3 times 0 is 0. Well, we talked about this before with the -4, and this is cannot be reduced. This has no real solution, no real solution, no real answer. They may even say if you're working in the real number system and they tell you that, it would actually be no solution. You cannot have this negative in this square root, okay? No negatives, all righty? No real solution, no real answer, okay? Perfect. Now, our next example, I'm not sure if we really need to go through this one or not, but here you've got g of x. The negative is on the outside, if you'll notice on this one. So because the negative is on the outside, you're good, you're fine. We've got, you can just, whatever you get, you take the opposite of it. Let's go ahead and do this first one at least. Let's do 3. G of 3 will have a negative 6 times 3 plus 4. So I'm just putting in 3, I'm just putting 3 in for the x's. And here we come up with, we have a negative. This is 18 plus 4, which gives us a negative square root of 22. Okay, well, can I reduce the square root of 22? Now, the reason I could have reduced, for instance, this 1 up here was because 1 times 1 gives me 1. So it comes out as a 1. If I had, let's kind of look at this idea and make sure you guys are clear on that. The square root of 25 is 5 because 5 times 5 is equal to 5. So what we're saying is that you have to have 2 of something in order for it to come out as a square root. All right, you have to be able to solve that x squared, 5 times 5, that gives you this. If I had, for instance, the square root of 36, well, this is 6 times 6, and I've got 2 of them, so it comes out to be a 6. And we'll be looking at this idea when we do cube roots and fourth roots. But because this is 2 times 11, it cannot be reduced. because something times itself other than a decimal. Now let's talk about that decimal here for a minute. And they may actually have you do this on a calculator, but let's look at the square root of 22. Okay, when you put this in, they're saying that we have a negative. The negatives comes down 4.690415576, and it just keeps going. So if you were to take this number times itself without the negative that's on the outside, if you were to take this number times itself, you're going to get 22. The problem is that this number keeps going, and it doesn't stop and it doesn't repeat. So when you have these radicals that cannot be reduced totally, this is a perfect square, 5 times 5 gives you that, then these are irrational. That's an irrational number when the radical cannot be reduced to an integer, or these whole numbers here. And so MyMathLab may ask you, you can round it off, to maybe negative 4.7, or they may want you to leave it like this. How do you know whether or not you should round it off or if you should leave it? If they say the word exact, you leave it. This is not exact because it keeps going, it never stops, and there's no way for you to write it all down. It's irrational. So when they want an exact answer, you leave it as a square root and of 22, because we don't have 2 of something in order to come out. All right, well, let's go ahead and do g of 0. All right, because we kind of talked about a lot of ideas there. The fact that this is irrational because it cannot be reduced perfectly like we were the other ones. This is a decimal that cannot be expressed as a fraction. It doesn't repeat. It doesn't, it never repeats, or it never stops. Therefore, it cannot be expressed as a fraction, and it's irrational. This right here, if MyMathLab says exact, find the exact solution, don't use your calculator, just stop. And we're going to work on these quite a bit and reducing as far as we can. But that's irrational. Okay, let's do g of 0 real quick. So again, if you put in 0, we have the negative outside. It's okay to have the negative outside. We have 6 times 0 plus 4. Okay, this is negative square root of 4. So we end up with a negative 2. The negative comes from the outside in the given problem. The square root of 4 is 2, because 2 times 2 gives you 4. Okay, all right. Well, let's go ahead and look at some other types here. All right, we've got expressions of the form the square root of a squared. Okay, we need to be careful with expressions of this form. It may seem like the answer will just be a, but this is incorrect. Okay, so what we're going to do is we're going to look at a couple of examples. So in this example right here, you're squaring the a, all right? So you've got 2 of these. Okay, this is the same thing as 5 times 5. And you've got to remember that the radical means the principal square root. So when you simplify over here, it has to be positive. All right, so that's what we mean by, you have to be careful here. So the answer is 5. Okay, it's a positive 5. Here, 0 squared is 0, so we get 0. The square root of 0 is 0. So you can do that. You can take the square root of 0. It's just 0. And now this next one, a negative 5 squared. The answer is not a negative 5. And the reason being is that we want the principal square root. So this one, if it were simplified, a negative 5 times a negative 5 is a positive 25, so the answer is 5. So even though we have a negative substituted in there, the answer is 5. What comes out needs to be positive out of these principal square roots. Okay, all right. Which brings us to maybe more of a formal definition, is that whenever you have this a and you're squaring it, the answer is the absolute value of a, which is what I did here. The absolute value, kind of remember, it's been a while since we've done absolute values. Absolute value means make it positive. Okay, that's what the absolute values mean. And so this right here is equal to a positive a. So whether or not you put in a positive 5 and square it, its principal square root is 5. If you put a negative 5 in and square it, you get a positive 25, so you come up with 5. So you get a positive 5 either way, all right? Okay, so let's look at how we write that with variables. Let's reduce these variables down. All right, let's look at this one right here. Okay, the square root of 36t squared. Well, 30, you'll do these separately. When you've got this multiplication, just handle these separately. Look at the 36 first. What times what gives me 36? And it needs to be the same number times itself. Well, the same number times itself is 6. Okay, you can't use the 9 and the 4. You can't use the 12 and the 3. It needs to be 2 of the same. So this would be 6. So we're halfway done. The t squared. What times what gives me t squared? Well, this means t times t, because remember you add exponents, and we'll look at some strategies on how to come up with this right here. T times t gives you t squared, just like 6 times 6 gave you 36. So that was 6. T times t gives you t squared, so it's t. The problem is what happens if the t squared, maybe the t was a negative 5 and you were squaring it. So that I know that when I find the answer, I have to take the absolute value. So your absolute value, you need absolute values around the t, meaning that no matter what I put in, whether I put in a positive or a negative, the answer has to be positive when it comes out, because it's the principal square root. So whatever comes out of that, whatever you substitute in, you need to take the absolute value of it. You could substitute in a 3 and then square it times 36, and you'll get 18. But you could also put in a negative 3, but you still need to get a positive 18 as an answer. All righty. Okay. All right, let's look at some more examples of that here. And I may come back to this, or maybe do some other ones over here. Okay, I have x plus 1 quantity squared. What this means is I have 2 x plus 1s underneath the radical. This could be rewritten as x plus 1 times x plus 1. Remember, that's what the squared means, is I have 2 of those. And if you have 2 of something inside this square root here, this principal square root symbol, it means that it's just going to be x plus 1. If you have 2 of them, it comes out as 1, like the square root of 25, 5 times 5. It comes out as 1, 5. Or the square root of 9 is 3 times 3, so the answer is 3. The problem is that it's the principal square root, so it needs to be positive. So put absolute values around it. Alrighty? Okay. Let's look at, another one here. I'm trying a different method of recording, so maybe it doesn't have such a delay. Let's look at this one here. If you're given a problem like this, go ahead and factor. So we have x plus, oops, sorry, not plus, sorry. Let me erase that a little bit better. X minus 4 times x minus 4. So again, chapter 5 and 6 come back at you. We've got x times x gives you x squared. A -4 times a -4 gives you a +16. -4 and -4 is a -8. So you could rewrite this as x minus 4 squared. Either way, you know you've got two of them. If you have two of them inside of a square root, you can bring them out. So here, the x minus 4 comes out, and there's nothing left inside. We'll be looking at these reducings here quite a bit more. But I want the principal square root. So whether or not the x minus 4 was positive or negative, the answer needs to be positive. So we'll use absolute values. All right. Now, let's go ahead and look at another example. A to the 8th. Okay, do I have two of the same thing that I'm multiplying by to get a to the 8th? Well, if you want a square root, you can just go ahead and divide this by 2. And we'll look at that idea later as to why, but you can do that. 8 divided by 2, and this only works with a square root, by the way, is 4. So a to the 4th times a to the 4th gives you a to the 8th. Where did I come up with the 4? Just take the your exponent divided by 2 for right now. The main thing to remember, though, is that I have a to the 4th times a to the 4th is a to the 8th. Again, you add exponents when you're multiplying. I have two of these inside of my radical, inside of my square root. And so this is going to be a to the 4th. Okay. It comes out, all right? These come out just like the square root of 25, 5 times 5, the 5 comes out. And then your answer is just 5. These will come out of your square root here, the principal square root, and you have a to the 4th. Now, we've been putting on the last two, we put absolute values down. But do we need absolute values here? Well, a to the 4th has an even power. So it will always be positive. You know, we don't need absolute values around it. It's not necessary, be redundant. Since this is even, this will always be positive. So we don't need the absolute values. Okay. Now, if it had an odd power, then yes, because odd powers can be negative, but it's an even power. So to put absolute values is redundant. We don't need it. All right, let's look at our next one. We want to reduce this principal square root. The reason I know it's going to be positive, that's what this symbol means, principal square root, as far as being positive. All right, let's see. Divide this by 2, and you get 3. So it should be t to the 3rd times t to the 3rd. Gives you t to the 6th, because you add exponents. I have two of them. They match. They're exactly the same. So they reduce down. This reduces down to t to the 3rd. Okay. They come out as t to the 3rd. Nothing's left inside of your radical. Now, do I need absolute values? Well, t to the 3rd, if t happened to be a negative number that I was going to put in, and you could put a negative number into here, and it'll become positive when you take it to the 6th power. And so, you know, it would be a positive, even though you're substituting in a negative, because anything, a negative to an even power is always positive, so we can find the square root, because it will be positive. It has to be positive inside to find the square root. But t cubed itself could be negative, because this is odd, so you do need the absolute values. All right. So, well, we'll kind of keep looking at that idea. Let's try one more. I'm gonna go ahead and do one more before we talk about the next idea, which isn't really different than this one. Okay, let's do. Let's say I had the square root of 9t to the 10th. All right. So I got the square root of 9t to the 10th. I'm going to move this back just a little bit. I want my hand out of the way when I'm writing. Okay. Now, again, you can take them separate. Let's say I want to reduce these. So what I'm going to do, I'm going to reduce this right here, the square root of 9, is 3 times 3. Okay, whenever whenever you have these two, you're solving that x squared equals 9. Whenever you have two of them, think of it as you can bring them out and as just a 3. But what about t to the 10th? T to the 10th is, here, we've got t to the 10th. I'll come over here. Divide that by 2, and you get t to the 5th times t to the 5th, which is t to the 10th because you add exponents. If you have the two of them that match, you're good to go. They come out. All right. And now you need to ask yourself, do I need absolute values? Sometimes you don't. If your powers are even, you don't need an absolute value because your answer is going to be positive no matter if A is positive or negative. But this is to an odd power. So you do need the absolute values because if you put a negative t in, it could end up being negative. So you can write it like that. Okay, put the absolute values around that. T times the absolute value. MyMathLab may even let you do this. Okay, either way, because it's not going to affect it. The 3 is positive either way, so it won't matter. All righty, let's look at actually some more examples here. But what happens as far as reducing, we're just going to be reducing these radicals. Sometimes we know, or the problem tells us, MyMathLab will tell you it sometimes, that the result is going to be positive. So you don't even have to worry about putting in a negative. In this case, so you don't need the absolute values. They're telling you that the answer is positive, so you don't have to worry about absolute values. You don't need to worry about putting these in if they tell you that the result will be positive. So whether or not you need absolute values or not, read the directions. If it doesn't say the results will be positive, if it does not say that, you'll need to put absolute values when you have odd powers. Otherwise, you don't. So let's go through some examples. As if you're expected to find, you're asked to simplify and assume that no radicands were formed by squaring negative numbers. So in other words, negative numbers were not included in the domain. You're not allowed to put in negatives for the A. And if we're not allowed to put negatives in, we don't need absolute values for these answers here. Okay. So again, assume that no radicands were negative. All right, so this right here is y times y. So the answer is y. And you don't need the absolute values because you're only using positives. So it's not necessary. Let's look at this one right here. A to the 10th. Okay, divide that by 2. A to the 5th times a to the 5th. I have 2 of those. So my answer is a to the 5th. I don't need, even though it's odd, I don't need the absolute values because they told me we're not going to be using negatives. So it stated that the domain is only positives. So we're only going to be putting in positives. We don't have to worry about it. Okay, let's look at the next one. You have to factor. You have to factor when you've got these here. So we're going to take a square root of 3x and 3x minus 1 minus 1. They have to match, you know, or this would be, it can't be reduced. This would just be the answer. These have to match. You have to have 2 of them. And we'll have 4 of them later, but because we have a square root, we only need 2 of them. So the answer is 3 minus 1. And again, no absolute values because our domain does not include negatives. So we don't have to worry about it. Okay, so that's kind of how you reduce these square roots, whether or not you need absolute values or excuse me, you need absolute values or you do not need absolute values. But they're done the same. It's just that sometimes on the answer, you'll have to put absolute values around odd powers. Okay, and then sometimes you won't have to put absolute values around odd powers. So, okay. And again, you're looking for 2 of something with these square roots. If you've got 2 of the same thing, they can come out of the radical. Okay, so let's expand it. And maybe this may be new for some of you, into cube roots. And this is kind of a long section. So, you can always stop it, do some problems that deal with square roots, and then come back and maybe look at the video and the cube roots, do some problems with some cube roots. But what we're doing when we want to, okay, square roots, if you think of a square root, the square tells you, a square is a 2. When you square something, you've got a 2. So it told you how many to look for. Well, a cube root, a cube is 3. So you have to have 3 inside of your cube root in order to take it out. So we're looking for 3 of the same thing multiplied together that give you this number. What are 3 things that, multiplied together that give us 8? And that would be our cube root. So here, I'm going to take this apart. So we use quite a few tree diagrams when we're reducing these radicals. This is 4 times 2, and the 4 is 2 times 2. So I know it's kind of scrunched in there, but I still think you can see the 4 is gone. I broke it into 2 and 2. That I have 3 2's in my 8. So the cube root of that is 2. Okay. But you're saying, well, the square roots, we had 2 answers at the beginning when we first started. When we were finding what are the square roots, we found 3 and a -3. Why do cube roots only have the positive answer, but not the negative when we're looking for the square roots, not just the principal square roots? Those are all positive. How come the cube roots don't have negatives? Well, let's look to see why. Again, we need to multiply 3 of the same things in order to get 8. So why not -2? Well, when I multiply a -2 times a -2 times a -2, I had to sneak that negative in there, I get a -8. Okay. -2 times a -2 is a +4. Then a +4 times a -2 is a -8, but I wanted a +8. So if you have 3 of something, okay, then if you have these negatives, your answer is negative. So when you have the cube root, you're only going to be finding 1, okay? It's going to be 2. And here's another thing. Can I have the cube root of a negative? Well, it kind of looks like maybe we can have a cube root of a negative and get a negative answer. What about a -64? What's the cube root of a -64? All right, let's break it apart. Well, I'm going to bring it over here just so we have a little bit more room. All right, 64. Okay, I know that I'm going to ignore the negative right now, and I'm just going to concentrate on what 3 numbers that are the same that I can multiply together and get 64. I'm looking for 3 of them because cube is 3. So let's start with 8 times 8. Okay. And let's break that down into 4 times 2, 4 times 2. Can you see 3 of something right now? Here's a 4, here's a 4, and these 2 make a 4. Let's check it. Take it on your calculator. What's 4 times 4 is 16. That's 16 times 4, this 4 right here, gives you 64. So as soon as you have the 3 of something, then it can come out. All right. And so the cube root of 64 is 4. What about the negative? Well, let's try -4 times a -4 times a -4. Well, a -4 times a -4 is a positive 16. 16 times a -4 is a negative 64. So your answer then for this one is a -4. So you can have negatives with cube roots. Well, and your answer, you just get one now. And when you're finding these cube roots here, if it's positive, your answer is positive. If it's negative, your answer is negative. But rather than looking at a square root or finding 2 of something, you need to find 3 of something multiplied together. That gives you that number, okay? Okay, so, and again, this is kind of the same type of an idea. The number C is the cube root of A. If C cubed, in other words, if that number cubed, that means -4 times -4 times -4 gives you 64, -64. So -4 cubed gives you -64. C is called the cube root. And how do you write cube roots? We talked about square roots. This is how you write a cube root. That's the cube root of A. So we would have the cube root of 64 or -64. You can have a negative in the cube roots. Okay, you can get an answer. There are three things I can multiply together that give me that -64, which is a -4 times a -4 times a -4. So if you have a 3 here, your answer can be negative. But if you have just the square root of -64, there isn't a number here. And that number, by the way, is called the index. So we have the radicand and we have the index. The index tells you how many you need to multiply together to get that number. If it's not there, it's called the square root, the principal square root. You want it positive. It's a 2 there, okay? But we just don't put it in. We just don't put that in. But it means you need 2 of something. And in this case, can't do it. But the square root of 64, I'm not going to put that 2 in there yet. If it's a positive 64 is 8. So there's a difference between the cube root, you want 3 of something multiplied together that give you this number. The square root, you want 2 of something multiplied together that give you that number in order to reduce it. Okay? All right. Now let's see what we've got on the next page. Boy, this is a long one. I'm really sorry, you guys. But you can do it. It would probably have been, you know, at least maybe 2 lessons. All right. Now, every real number only has 1 cube root, and we talked about that. See, we only had 1 cube root. We had a 2 or we had a -4. Okay. Every real number has only 1 cube root as opposed to 2 square roots, unless we use the symbol, which means, and sometimes we limit this one to the 1. Thus, we don't need the absolute values ever when taking a cube root. So the answers in cube roots can be positive or negative. So we don't need the absolute values, only with our square roots. And actually, I'll go ahead and put this plug in. Whenever your index is even, the index is even, this right here, whenever this index is even, you have absolute values, unless they limit the domain in the question. Okay, so if that's an even number like this one, you need absolute values, unless they limit it and use the radical sign and limit the domain. But then here, if it's odd, you can have negatives, and you don't need, so you don't need the absolute value signs. Okay, let's go ahead and go through this. Let's work with some cube roots. And there are some of these you guys may want to memorize. What's the cube root of 125? Well, it's a cube root, it's odd, so your answer is going to be positive if inside is positive. Okay, that was nice. That was easy to do. And you want three numbers multiplied together that give you 125. And if you do, it can simplify it to a single number. Now, in this case, this is 25 times 5, 5 times 5. I have 3 5s in 125. So this is read, the cube root, okay, the cube root of 125 is 5. Don't worry about absolute values. Yay, that's nice. All right, let's look at the next one. And if it's an odd index, you can have negatives inside. Okay. What 3 things do you multiply to get a negative 27? Well, 27 is 9 times 3. Oops, excuse me. And this is 3 times 3. So you come up with 3 3s. So we have our 3 of something. We have 3 3s, and we want them all to be negative so that when I multiply them, I get a negative 27. Remember, when you have an odd number of negatives, all these things are kind of coming together. When you have an odd number of negatives, your answer will be negative. So we come up with a negative 3 for an answer. Okay. All right, what about 0? Can we do the cube root of 0? We did the square root of 0. Can you do a cube root of 0? Well, let's go ahead and put in f of 0 equals the cube root of 0. And the answer is 0. Yes, you can. You can have the cube root of 0. It's 0. All righty. Let's try one more. And, you know, a lot of you have a cube root on your calculator. Without seeing the individual calculator, it's kind of hard to tell as far as, you know, what 3 numbers multiplied together give you a certain number. So if you look, those of you that have like a graphing calculator like I do, a TI-84, your cube root is found under your mode. So let's look at that. Nope, sorry, it's found underneath math. All right, so let's quit. Clear. All right, so okay, so if you look underneath your, if you go to math right here, this was your math key, it's underneath the alpha key, and you push it. This is pretty nice. If you guys haven't used this before, this will change a decimal to a fraction. You just have to press enter here and it'll change it. It'll change a fraction to a decimal. It will cube a number, take it times itself 3 times. But if you look at number 4, it will find the cube root. And so you can either arrow down to number 4, or you can just press 4. And if you press 4, then you could put in 125 and it'll give you 5. All right. Now, and also, if you put in, we're going to be seeing here in a minute, if you go to math, if you do 4 cube root, you can put in 216. And it's 6. That tells you that 6 times 6 times 6 is 216. We'll be doing one of those here in a minute. Now, if you don't have one of these calculators and you have just a scientific calculator, a lot of times you're going to want a key that looks like this. And sometimes they may even put the Y right there. And that'll give you cube roots, 4th roots, 5th roots. Sometimes we want 5 of something that multiply together give us a number. This key right here will do this. Now, it depends. You have to kind of work with this on your calculator, but a lot of times if you want the cube root, you'll push 3 first on your home screen, and then you push this key, and it will and then you push the key, this key right here, and then it will give you this. Okay, this will pop up. It'll just kind of put the X right up here, that index. And then you just type in your 125 or whatever. But, so some of you may have this key, some of you may have the graphing calculators. So, but you know, those are there in case you don't have some of these memorized. And it takes a while sometimes to break these down, and so you may not want to spend the time, and the calculator will do that. Okay, let's look at a couple examples here of this negative 24. G of a negative 24. We put in a negative 24, so we have the cube root of a negative 24 subtract 3. And we end up with the cube root of a negative 27. Okay. And that gives us a negative 3, because we've done this one. Yeah, we did this one earlier in the problem above. And so we end up with a negative 3, cube root. So again, we're looking for 3 of something. So it does matter. That index makes a huge difference. You know, it tells you how many of something you need in order for it to reduce down to a negative 3. Okay. Okay, let's do an example here of looking at what happens if I have a variable underneath there. Well, if you look at the last one's with the square roots, the 2, we divided by 2 to see what times what, you know, we could use for these exponents. So if you have a cube root, we'll be dividing by 3, and we'll explain why in later ones, why that exactly is working. But you deal with the negative 8 first. What 3 things, our index is 3, what 3 numbers multiplied together give you a negative 8? And the 8 would be a 2 times 2 times 2 gives you 8, and you just carry the negative. So negative 2. Negative 2 times the negative 2 times the negative 2 gives you the negative 8. You can have a negative if the index is odd. Now, to find out this right here, take 3 divided by the 3 leaves you with y to the first. So what we're saying, let's see if it's true. Is that true? Y to the first times y to the first times y to the first gives you y cubed. And to come up with that 1, that exponent, I just took 3 divided by 3. And it works because you add exponents. So again, 1 plus 1 plus 1 is 3. I'm just checking, make sure that that's right. I have 3 of those y's. I'm looking for 3 to reduce it. So my answer is this, negative 2y. And there's your answer. Because a negative 2y times a negative 2y times a negative 2y, if I multiply those together, 3 of them, I get back to what's under the radicand. I get back to the radicand. And then the index tells you how many you need to get back to the radicand. Okay, so many ideas here, so many ideas. Okay, now this kind of explains what I was talking about, whether or not it's an even index or if it's a an odd, and they're calling it nth root. But this box kind of explains that. So let's go ahead and talk about it. Even in odd nth roots. So like you have the 3rd root, 4th root, okay, cube root, to the 4th root, maybe of the 5th root, the 6th root. There are more than just square and cube roots. There's 4th roots, 5th roots, and so on. They behave similarly to the square roots and the cube roots. If it's even, every positive number has exactly 2 real even roots, 1 positive and 1 negative. Okay, so if it's positive, you're going to have you can have 2. You can have a positive or you can have a negative. If this is even though when we do the principal square root, we're just interested in our positive answers. The even nth root of a negative number does not exist. What does that mean? You cannot have, if this is even, if this index is even here, you cannot have a negative, like a negative 4. Cannot be done. If that index is even, there are no negatives inside. And for now, you don't have a real solution. There's no real solution, okay, with real numbers. That's what that means. There's no real solution. There's no solution with real numbers. Now, if you use the symbol, if you use the radical symbol, that means we only want the positive. If you use the radical, it denotes the principal, even, nth root, and thus must be positive. So we often need absolute value signs, unless in the directions they limit it to positives only. Then you don't need your absolute value signs. But most of the time, when you see this symbol, we'll be working with this symbol, we want just positives, okay? We're not going to use the negatives. Now, if it's odd, you're only going to get one, okay? One real odd root, which shares the same sign. So if you have a positive and you have an odd, so in other words, if you have a cube root of a positive number, you're going to get one positive number. If you have the cube root of a negative number, you're going to get one negative number. The sign matches, it just goes down. And we can do the odd roots of a negative number. We do not need absolute values when working with odd numbers. We don't have to worry about our absolute values. Okay, we're going to simplify some more. And I think that that's kind of what we'll be doing here for a while, is just kind of learning how to simplify these. And then we're going to do domains of radicals, which we've done before, but it's a good idea to review. You've got a final coming up in about 3-5 weeks. Okay, here, simplify. I want the fourth root of 16. I want 4 of something multiplied together that gives me 16. I want the principal square root. So I'm only going to be looking for the positive here. My answer will be positive. There are no variables, so no absolute values. Okay. So this is positive, so you can do this. If this were negative, there would be no real answer. Okay. But here, I'm just going to go ahead and break it down. This is 4 times 4. If this, without that 4, the square root, if I just wanted 2, then I would be done. Here, I'm going to keep breaking these down. I need 4 of something that I'm multiplying together. And in this case, I have 4 2's in 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So I have 4 2's. I wanted 4 of something. So my answer is 2. And there's your answer. Don't worry about absolute values unless you have variables. Okay, good, perfect. Let's look at another one. So I'm glad we're reviewing some more of these. The negatives on, look at A, the negatives on the outside. Okay, so we're good. As long as it's not on the inside, then you would say no real solution. But here, not really necessarily a solution, but it can't be simplified or not possible. I don't know how they're going to word that. So I know just from the previous problem that that's equal to 2, because there are 4 2's in this right here. Because of the negative on the outside, it means take a -1 times whatever you get. So your answer is a -2. That's the only way you're going to get a negative when you have an even, is if the negative's on the outside. That's it. So this one is cannot be reduced, no real solution. It cannot be done. It does not exist. No real solution exists. Okay. So notice where the negatives are and what the answers. You guys got that? Great. Let's look at this one. Okay. We're going to look at the 81 separate and x to the 4th. Let's concentrate on the 81. The index is 4. So this is red, the 4th root of 81x to the 4th. The 4th root of 81x to the 4th. So we have the 4th root. Now we want 4 of something. Is there 4 of something in an 81? If not, the 81 has to stay underneath this 4th root. But let's look. So we're going to go ahead and break it down. I think I'm going to move it over here. Let's just concentrate on the 81. 9 times 9, 3 times 3, 3 times 3. And we have 4 3's. Perfect. So the fourth root of 81 is 3. The fourth root of 81 is 3 because I have 4 of them. That tells you how many. It's kind of like a gatekeeper. It tells you how many you have to have before it's allowed to come out of the radical sign. So you have 3. That's part of my answer is 3. Now I'm going to look at the x to the 4th. Well, I need 4 things multiplied together. Let's take 4 divided by 4, and that gives me 1. So when I'm reducing this, it means I've got x to the 1st, x to the 1st, x to the 1st. I have 4 of those. 1, 2, 3, 4. You add the exponents. So I've got 4x to the 4th. I was going to use a tree and change my mind. So it reduces down to just an x. So I have got 4 of these. Just like I had 4 3s, I have 4x to the 1st. This is even. This right here could be an odd number. So I need absolute values. Okay. So when you have an even index and you reduce it down and you come up with an odd out here, you have to use absolute values because it has to be positive. All right, let's look at another one. I have the 6th root. So I'm saying, okay, I need 6 of the same thing in order to reduce this. I'm hoping you guys are kind of catching on. There's a lot of so many little ideas. This is y plus 7 to the 1st. Why first? Why am I using first? Well, 6 divided by 6 is 1. So I'm going to say, so if I have, that's where I'm coming up with the first. Y plus 7. 1, 2, 3. Y plus 7. I've got 6 of these. I have 6 y to the 1st. 1 plus 1 is 2, 3, 4, 5, 6. You'd add the exponents on these common bases. If you have 6 of something, it can reduce out. I have 6 of these, so this is equal to y plus 7. Even index, this is, can be odd. I mean, you could put a negative and get a negative here. So I'm going to use absolute values. Yeah, I guess don't make it too hard. Let's try another one. And then I might come up with another one here. I was just thinking about it, just to make sure. 5. Okay, 5 here. This index is odd. So I don't have to worry about absolute values. And what comes out, comes out. If it comes out a negative, if you would have had a negative 32, you're going to have a negative when it comes out. All right, just kind of the signs just stay the same. So I don't have to worry about absolute values because that's odd. And odds can have negatives inside. So let's look at the 32 separate. This is 32 times, so I'm going to look at this separate. This is, let's go with 8 times 4. Okay. This is 4 times 2. I need 5 of something. Right now I don't. 2 times 2, 2 times 2. Well, looks like I ended up with 5 2s in 32. 1, 2, 3, 4, 5. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. So this is 2. Okay. Now let's look at our x minus 1s to the 5th. I have 5 of those. I have 5 of those, and I needed 5 to come out. So this, if I take 5 divided by 5, I get x to the 1st. That tells me what the power is. And I have 5 of them. And I want to do 1, 2, 3, 4, 5. Okay, so I have 5 x minus 1s to the 1st. That's what that means. This index tells me I want 5 of something to come out. Well, I've got them. I've got 5 of them. And so I end up with x minus 1. So there's your answer. No absolute values like I had in the other ones, mainly because it's an odd. So we didn't need that. Okay. All right. Now what happens? Maybe we'll leave that. it's really important if you guys have questions after watching this. You learn by doing the homework and trying it yourself. You've got to contact me so that I can go through this maybe differently, go through it slower, more step by step. All right. What we're going to look at now are finding the domains. So when you want to find the domain of these functions, if this is even, I know that I can only put in positives. So we've looked at this idea before, but it's a good idea to review. Because this has to be positive, another way of saying positive is to say it has to be greater than or equal to 0. We know it could be equal to 0. We've taken the square root of 0, the fourth root of 0. So another way of saying what's inside is positive is to say what's inside is greater than or equal to 0. And you solve that, and there's your domain. So we have -7. I'm going to move over here. And then you divide by a -3. But when you divide by a negative, you flip the inequality. So my x's have to be less than or equal to +7/3, because a negative over a negative is a positive. There's your domain. Any x less than or equal to about 2 1/3. All right, or 7/3. Just leave it as 7/3. There's your domain, because what's inside has to be positive. And another way of saying positive is to say that a number, this represents a number, is greater than or equal to 0. Okay. Find the domain of each of these functions. Okay, here, the 2x, it doesn't matter about the -3, but what's inside must be greater than or equal to 0. So it would be like when we were doing fractions or rationals, we ignored the numerator, and all we paid attention to was the denominator could not be 0. That's how we found our asymptotes and things like that. But here, you're looking at the radical. What's inside has to be positive. No matter what else is going on around it, what's inside has to be positive, and you solve it. And then divide by 2. X is greater than or equal to 5/2. We didn't divide by a negative, so we did not have to flip the inequality. So there's your domain. X is greater than or equal to 5/2. Great. Let's look at the next one. I know that x squared plus 1 has to be greater than or equal to 0. If you square a number and add 1, will this ever be negative? Even if you put in a -10, a -10 squared is 100. So this is always positive, and if you add a positive, you're going to get a positive number no matter what. So this is always positive, so it's a -infinity to infinity. Because if you square a number and add 1, it's always going to be positive. Okay? All right, perfect. I think that's enough for domains. All right. We're going to look at a story problem. We're going to look at some graphing. What do these look like graphed? I'm graphing these roots, because we know what an even power looks like. We know what an odd power looks like, but what about these roots, these square roots? What do they look like? But before we do that, let's do an example. And I'm not sure when this book was written, but I guess we could always compare this model they came up with the actual. I don't know what the actual is. Maybe somebody does, and they can text and share it with me, and we can I can put in the next video. But The number of monthly active Twitter users in millions, you have to remember this is in millions, can be modeled by the radical function f of x equals this. We've got a radical in there, where x is the number of years since 2010. So x represents how long it's been since 2010. Estimate the number of active Twitter users that there will be in the year 2020. All right, so we've got this function here, and 568.1 square root, we're looking at the square root of 0.003 x minus points. I don't put the zeros in front of my decimals, but you can. I'll tell you where some danger sections are here. I don't like writing on this surface, so I'm going to put a piece of paper underneath that. Okay. All right, that's a 1. Okay, now what is the x? All right, well, x represents the number of years since 2010. Well, they want to go from 2010 to 2020. That's 10 years. So all you need to do is substitute in 10 into this equation, and that'll tell you how many millions of Twitter users they expected in the year 2020. So you could type this in. Those of you with a graphing calculator, you could just type this in, or ones with a display, 0.0035 times 10 minus 0.001. Now, if you have a graphing calculator like mine, you have to arrow out of the radical because this part is not under the radical. So be very careful when you're using your calculators that you don't go like this, and if you don't arrow out, your calculator is going to put this underneath the radical, but you don't want that. Okay, you want it to find the square root of this part. You want to find the square root of this part and then times it to this. So it'll do inside, it'll take the square root, it'll multiply it by this, and then it will subtract 6.6109. I hope I copied all that down right. I think I did. And so you just type that into your calculator, and I should have done this before just to save you guys from watching, but I will do that maybe here. So we have 568.1, and then you do your square root, which in my case is a blue key, square root of 0.0035 times 10, subtract 0.0016. Now you see it wants to keep going underneath the radical. Sorry, I don't know if I turned off there. Yeah, that might help, the glare. Okay, then it would keep going underneath the radical, so you have to arrow out of that. Okay, now it's no longer under the radical, and you do your subtract 6.6109, enter. About 97.2 million. So I'm going to turn this light back on. All right, so we've got roughly, mine came out to be, and I really don't know what the actual is, 97.21 million. Is that millions? Yeah, it's got to be more than that. So Twitter's pretty popular. I haven't used Twitter, and I'm old. So okay. Anyways, so there's an estimate, and those of you that are in your science, you could find the error. You take the actual minus what you got divided by the actual to find the percentage error. But, okay. Anyways, let's go ahead and look at some graphs here. Now that we've kind of done one sample of a story problem application, pretty easy. Graphs, what do these look like? Well, we know that when we're looking at a graph, we know that we cannot put negatives in here, which means we have eliminated this entire side of the of the graph. Now, so we can't put in a -1. We can't put in a -2. Those are over here. These sections are not in the graph. Those sections are not a part of it. We can't put these x's in, so we can't even use those. Our first number we can use would be 0. Square root of 0 is 0. Let's plot some points. So we'll just plot some points here. So if x is 0, y is 0. What if x is 1? So what's the square root of 1? Well, it's 1. So we'll go to 1, 1. I'm going to pick some numbers that are easy. 4. What's the square root of 4? Well, this is principal square root. So you've noticed that we're using this radical. That's principal square root. 2, positive 2. 1, 1, 2, 3, 4. So we go 4, 2. And we could do 9, 9, 3. These are square roots that we know. But it ends up looking like this curve. It kind of goes like, it keeps going up. It's kind of a curve. It's not real fast, but it does keep going up. And so it's this curve that starts at 0, 0 and goes up for your square root. What about 4th roots? Yep, same shape. 6th root, same shape. 8th root, same shape. Okay, it's just that it wouldn't be quite as high as the square root. They would be kind of down here for your square roots, for your other even roots. Okay, but they all have basically the same shape. What about our odds? Well, when you do these odds, they can you can put in negatives. So we're not limiting. We can put in negatives, and we will. Let's put in some negatives, let's put in some positives, and let's see what we get. Oh boy. Okay, let's put in a -8, a -1, 0, 1, and 8. So 1, 2, 3, 4, 5, 6, 7, 8, -1, 2, 3, 4, 5, 6, 7, 8. -8, -1, 1. I did finish up there. Okay. 1, 2. All right. Let's put in a -8. So if we put in a -8, what's the cube root of a -8? I need 3 of something. Well, we've kind of already done this one. It's a -2. When you have odds, the negative just carries on. 2 times 2 times 2 is 8. -1. So I'm putting these x's in and seeing what the y's are. -1 times a -1 times a -1 gives you that. So, all right. 1 times 1 times 1, 3 ones. So if you have 1 times 1 times 1, 3 ones, and you come up with a -1, the sign just goes around. 0 is 0. What happens if I have a positive 1? Well, the cube root of a positive 1 is +1, because 1 times 1 times 1 is 1. You've got 3 of them multiplied together. +8, the cube root of a +8 is just a +2, 3 2s. So if we plot these, -8, -2, -1, -1. Let's kind of go over my -1, but that's okay. 0 0, 1 1, 8 2. So what happens is it looks kind of like this, where these kind of keep going up slightly and down slightly, but it's kind of like this curve here for your cube roots. Okay, so, and 5th root and 7th root and 9th root, these odd roots will have this shape to them, whereas your even roots will have this shape to them. Oh wow, you guys, I think I'm done. And if you hung in there, bless your heart, that was quite a lot. There's a lot of ideas. Please do the homework, and please contact me if you have any questions at all, and I'd be happy to help you out. Because like I say, there's a bunch of little ideas in this one. So, all right. Well, you guys take care. Hope you guys are doing fine and keep up with the homework. Good luck with the test. If you know, some of you have already taken that exam 3 over chapter 7, but okay. Well, you guys take care. All right. Bye-bye. Okay, I'm gonna stop sharing and stop the recording.